In an unprecedented turn of events, the 3I/ATLAS project has just reached new, uncharted heights, its scale now exceeding what experts believed was possible. The latest data released on September 30th, 2025 from multiple research satellites and ground stations reveals staggering growth in both size and complexity, signaling the dawn of a new era in space exploration. This dramatic leap isn't just a technical achievement, it represents a monumental shift in the very way we understand large-scale cosmic projects. For years, the 3I/ATLAS initiative has been a quiet yet ambitious venture, with the world watching as its goals evolved. What began as a small yet visionary concept has now become something much, much larger. With over 400 million data points collected in the last quarter alone, this growth is no longer speculative. It is tangible, undeniable, and staggering. The sheer volume of data coming from a network of advanced telescopes and satellites spread across various global hubs confirms what many had only whispered about. 3I/ATLAS is no longer a singular initiative. It's a global force that could reshape industries and redefine technological boundaries. This massive surge in size and capabilities also brings with it a number of implications. The integration of the latest AI-powered analytics systems, paired with real-time data processing on an unprecedented scale, points to a project that is quickly outpacing its initial ambitions. But what does this mean for the future of scientific inquiry, for the industries and economies that depend on breakthroughs from such projects? Could 3I/ATLAS sudden growth be the first indicator of a new phase in our relationship with the cosmos and our technological capacities to explore it? The numbers are difficult to comprehend, but when viewed through the lens of space exploration history, they signal the beginning of an entirely new chapter. The project is growing faster than we can measure, yet its ultimate potential remains cloaked in mystery. Could this be the beginning of something truly groundbreaking? As we begin to unpack this new reality, it's essential to consider not only the data we now have, but the profound questions that remain unanswered. What's driving this unprecedented growth? And more importantly, what does it mean for us, on Earth and beyond? Stay tuned as we delve deeper into this extraordinary development. The future of 3I/ATLAS has just begun, and the next steps could change everything. The initial stages of 3I/ATLAS were met with curiosity, but the true scale of its growth was barely imaginable. As the latest data reveals, 3I/ATLAS is not just expanding in physical size, but in its operational scope. This development is not just about the system's sheer size, it's the rate at which it has grown in the last few months that has left experts and stakeholders alike in a state of wonder. Previously, the project's ambition was clear but limited, aimed at tackling specific areas of astronomical research and technological applications. However, in recent months, the reach of 3I/ATLAS has expanded far beyond what anyone could have predicted. This surge in expansion raises the obvious question: how did this massive leap happen so quickly? And what does it mean for the future of space exploration and scientific research? To understand this, one must first consider the infrastructure behind this growth. 3I/ATLAS, initially built as a network of satellites and telescopes for deep space observation, has now been expanded with cutting-edge AI technologies, automated processing systems, and an interwoven network of research stations that span across multiple continents. In a matter of months, 3I/ATLAS has nearly tripled its capacity, increasing the number of active observation points from 150 to over 400. This exponential growth in physical and technological assets is a testament to how fast the project is accelerating, and how quickly it's becoming a significant player in space-related research and beyond. This dramatic expansion also speaks to a larger shift occurring in the way we approach cosmic research. Historically, massive scientific projects of this scale have taken decades to materialize, with slow and steady progress marked by incremental advancements. But 3I/ATLAS is rewriting that playbook. This rapid transformation is reflective of a new era in research, one driven by real-time data processing, AI-enhanced simulations, and collaborative global efforts. Even more fascinating is the way this data is being used. The project's researchers are now able to process petabytes of information almost instantaneously, with AI models analysing complex space phenomena on the fly, making decisions and adjustments faster than human teams ever could. What once required months of data analysis now takes hours, and in some cases minutes. It's this technological acceleration that has fueled the meteoric rise of 3I/ATLAS. Its systems are not just operating at full capacity, they are doing so with a level of sophistication and efficiency never before seen in this field. But perhaps the most intriguing question remains: what are the driving forces behind this explosive expansion? While data processing and AI infrastructure are key components, it's also clear that a much larger force is at play, something that could revolutionize the very nature of space research. This explosion in growth may not be purely technological, it could be the result of new breakthroughs that will further illuminate our understanding of space, time, and perhaps even the very nature of the universe itself. As we continue to explore what's driving this growth, it's important to understand that 3I/ATLAS is no longer just a research initiative. It's a global enterprise with the potential to impact everything from technological innovation to global politics. What started as an academic pursuit has now become something far more expansive. It's clear that we are only beginning to scratch the surface of what 3I/ATLAS could mean for the world. This section has only begun to uncover the mysteries behind the growth of 3I/ATLAS. What has been unveiled so far is just a glimpse of the scale and potential this project now holds. As we move forward, the implications of this expansion will continue to unfold, with new questions emerging as rapidly as the data itself. What might be the next big breakthrough? Could the entire framework of space exploration be redefined by this unexpected growth? And what exactly will this mean for humanity's relationship with the cosmos? Stay with us as we explore what comes next in this unfolding story. As we delve deeper into the causes of 3I/ATLAS's rapid expansion, it becomes increasingly clear that the project's growth is not merely the result of technological advances or infrastructural improvements. At the core of this unprecedented leap is an alignment of several powerful forces, technological, economic, and geopolitical, that have converged to propel the initiative into a new phase of development. The most obvious factor contributing to this rapid growth is the groundbreaking advancements in data processing and AI integration. In the span of just a few months, 3I/ATLAS has transformed into an AI-powered powerhouse capable of processing an unparalleled amount of real-time data. This isn't just about handling bigger data sets, it's about making decisions faster, analyzing complex phenomena in milliseconds, and deploying solutions with a speed and precision previously unimaginable. What was once a labor-intensive, human-led process is now being handled by machines capable of learning, adapting, and evolving in real time. However, the story behind 3I/ATLAS's rapid expansion isn't entirely about technology. A closer look reveals a coordinated effort among international governments, private entities, and research organizations, all of which have a vested interest in the success of the project. The collaborative nature of 3I/ATLAS is something that makes it truly unique. This is no longer a solitary scientific initiative, but a global effort with far-reaching political and economic implications. For example, national governments are eager to support and invest in projects like 3I/ATLAS because they represent not just scientific achievement, but geopolitical influence. Space research has long been a field where global powers have competed for dominance. Countries that can claim breakthroughs in space exploration position themselves as leaders in technological innovation, capable of influencing not only global scientific discourse, but also shaping industries on Earth. As a result, 3I/ATLAS has attracted massive funding from international coalitions seeking to harness its potential for technological advancement, national security, and economic prosperity. The role of private enterprise in this growth cannot be understated either. With the rapid commercialization of space, companies are more motivated than ever to participate in large-scale scientific initiatives. 3I/ATLAS has proven to be not only a hub of cutting-edge research but also a fertile ground for innovation, drawing in private sector investment that fuels its growth. Companies with an interest in AI, quantum computing, and data analytics are now partnering with 3I/ATLAS, bringing their technological expertise to the table in exchange for access to exclusive data and the promise of commercial applications. This private-public collaboration has proven to be a catalyst for innovation, and its impact is already visible in the rapid development of space-based AI systems, autonomous research satellites, and advanced quantum computing applications. These technologies are not only enhancing the capabilities of 3I/ATLAS, but are also providing commercial solutions that could redefine industries such as telecommunications, defense, and even healthcare. As 3I/ATLAS continues to evolve, it's clear that these forces, technology, politics, and economics, are propelling it forward at an astonishing pace. What remains to be seen is how these forces will continue to interact as the project scales even further. As 3I/ATLAS grows, it's likely that new alliances will form and perhaps even new challenges will emerge. The question now is, can 3I/ATLAS maintain this rapid growth trajectory, or will the complexity of managing such a massive, multifaceted initiative begin to strain its systems? What we know for certain is that the forces behind 3I/ATLAS are not just driving growth, they are fundamentally transforming the landscape of space research, technology, and international collaboration. The scope of this transformation is something we are only beginning to understand. But one thing is clear, the rapid acceleration of 3I/ATLAS is not just a matter of scaling up, it's about setting new standards for what's possible. As we continue to watch the unfolding narrative of 3I/ATLAS, one thing stands out. This is a project built not only on the foundation of science and technology, but also on the convergence of human ambition and the quest for discovery. Could the implications of this growth stretch beyond the technical and the geopolitical, reshaping the very fabric of human exploration? This question remains as we continue to explore the boundless possibilities of 3I/ATLAS. As 3I/ATLAS continues to grow, the expansion is revealing more than just technological advancements or shifts in global alliances. Hidden within the vast sea of data and cutting-edge systems are secrets that might forever alter our understanding of space, technology, and even the fabric of reality itself. Each layer of the system's growth brings with it new revelations, some of which may take years to fully comprehend. These discoveries aren't just about new capabilities, they're about uncovering mysteries that have long been hidden in the cosmos. One of the most intriguing developments is the discovery of unexpected cosmic phenomena through the newly expanded network of 3I/ATLAS. With its expanded reach, the project has begun capturing unprecedented data on dark matter, cosmic radiation, and gravitational waves, three areas that have eluded scientists for decades. The data being collected suggests that 3I/ATLAS might be on the verge of uncovering entirely new forms of celestial bodies or forces that exist outside of current scientific understanding. This raises a fundamental question. What if the universe contains phenomena far more complex and unpredictable than we have ever imagined? The discovery of these new cosmic forces could have far-reaching implications for theoretical physics, particularly in the areas of string theory and quantum mechanics. String theorists have long hypothesized the existence of hidden dimensions, alternate realities, and exotic particles that remain undetected by conventional telescopes. Could the expansion of 3I/ATLAS provide the missing link between our current understanding and the next frontier of physics? Preliminary data suggests that this might be the case. Furthermore, the increased sensitivity of 3I/ATLAS's instruments has allowed researchers to observe anomalous gravitational waves that seem to defy the current models of general relativity. These waves, which travel faster than expected and with irregular patterns, could indicate the presence of extra-dimensional objects or unseen energy fields operating on a scale beyond our comprehension. If these anomalies are confirmed, they would not only rewrite our understanding of gravity, but also challenge fundamental assumptions about the nature of space and time. But these revelations are not just theoretical. As 3I/ATLAS collects more data, it is becoming increasingly clear that we may be on the precipice of uncovering something much more profound: the interconnectedness of all matter. Recent findings suggest that the boundaries between physical reality, quantum phenomena, and even human consciousness might not be as distinct as we once thought. The project's data, in conjunction with recent advancements in neuroscience, could potentially open new avenues for exploring the connection between the universe and our own perception of it. As these groundbreaking discoveries continue to emerge, it's essential to acknowledge the speculative nature of these findings. While we are witnessing the unveiling of new cosmic phenomena, we still lack the full understanding to make definitive conclusions. Each new piece of data adds complexity to an already intricate puzzle, and the answers may be far more elusive than we anticipate. What we know for sure is that 3I/ATLAS is pushing the boundaries of human knowledge in ways that were once thought impossible. So what do these discoveries mean for the future? If 3I/ATLAS is indeed uncovering new dimensions of reality, what will the implications be for technology, human society, and our place in the universe? These questions are likely to remain unanswered for some time, but as the project continues to grow, it's clear that the journey into the unknown is just beginning. The secrets of the cosmos are being slowly revealed, and as we gain more knowledge, we may find that the very laws of nature are not as immutable as we once believed. With each new piece of data, we are inching closer to a profound truth, one that could redefine everything we know about the universe and our role within it. The future of 3I/ATLAS is no longer just about technological growth. It's about unlocking the mysteries of existence itself. And as we continue to follow the trail of this unfolding story, it's clear that the questions will only grow deeper, more complex, and more awe-inspiring with time. Stay with us as we dive even further into the enigmatic discoveries waiting to be made within the expanding reach of 3I/ATLAS. The journey is far from over. The rapid expansion of 3I/ATLAS is reshaping not just our understanding of space, but also has far-reaching implications across various global sectors. As the project evolves, its impact is extending beyond space exploration into technology, economics, politics, and society, marking a transformative moment in human history. One of the most prominent effects of 3I/ATLAS is on technological advancement. As the project pushes the frontiers of space research, it drives innovation in industries ranging from AI to quantum computing. The sophisticated AI models developed for data analysis in 3I/ATLAS are revolutionizing other sectors, such as healthcare, cybersecurity, and finance. The speed and precision of these systems are setting new standards, enabling advancements like more accurate medical diagnostics, improved cybersecurity frameworks, and advanced financial modeling techniques. A significant consequence of 3I/ATLAS's expansion is the potential to redefine global cooperation. In an increasingly divided world, the project exemplifies how collaboration can transcend borders. It is a rare instance of multiple nations, private corporations, and academic institutions coming together with a shared purpose. The success of this collaborative model could serve as a roadmap for addressing other global challenges, including climate change, public health crises, and geopolitical instability. The wealth of data being collected by 3I/ATLAS offers tremendous potential for shaping global governance. The insights derived from this data can help inform policy decisions in areas such as environmental protection, disaster management, and space law. As the project continues to grow, 3I/ATLAS is likely to play an increasing role in shaping international regulations and agreements governing space exploration and the sharing of space-based resources. However, with these advancements come pressing ethical concerns. As 3I/ATLAS integrates more with private sector technologies, questions about data privacy, surveillance, and the commercialization of space resources are becoming critical. The rapid pace of this progress raises concerns about the potential exploitation of space for profit. Who controls the vast amounts of data generated by the project, and how will it be used? These are vital questions that require careful consideration from policymakers, scientists, and the public. The societal implications of 3I/ATLAS are also profound. The expansion of the project highlights the growing importance of STEM education and global scientific literacy. As the world's brightest minds collaborate on 3I/ATLAS, there is an increasing emphasis on preparing future generations for careers in cutting-edge fields like AI, space exploration, and global collaboration. Educational systems are being urged to adapt and prepare students for roles that will be integral to the future of these advancing technologies. Economically, the expansion of 3I/ATLAS is creating new industries and high-demand job opportunities. The project's growth is driving the development of space-based AI systems, advanced satellite technologies, and quantum computing applications. These innovations are revitalizing industries that were once considered niche, such as aerospace and data science. The surge in demand for skilled labor is fueling economic growth, particularly in high-tech sectors that are essential to the global infrastructure. At the same time, the rapid development of 3I/ATLAS could lead to new geopolitical tensions. Access to and control over space-based technologies is increasingly seen as a source of power. Nations with advanced space initiatives will hold significant influence on the global stage. The race for dominance in space technology and data could spark a new space race, where the competition is not just about reaching outer space first, but controlling the most valuable resources and data. This evolving power dynamic is likely to shape future political relations in ways that are still unfolding. In conclusion, the global impact of 3I/ATLAS is a double-edged sword. On the one hand, its expansion promises groundbreaking technological innovation, global cooperation, and economic growth. On the other hand, it introduces new ethical, political, and social challenges that must be addressed. The direction that 3I/ATLAS takes in the coming years will not only determine the future of space exploration, but also influence global collaboration, governance, and technological progress. As we continue to track the developments of 3I/ATLAS, it is essential to recognize its broader implications. What may initially appear to be a scientific endeavor is, in fact, a transformative force that will redefine industries, international relations, and societal structures. The future is unfolding, and 3I/ATLAS will undoubtedly play a central role in shaping it. Stay tuned as we continue to explore its profound impact on our world. The rapid expansion of 3I/ATLAS is driven by a complex array of advanced technologies, such as artificial intelligence, AI, and quantum computing, which are transforming not only space exploration, but a range of other fields as well. These technologies have not only enabled 3I/ATLAS's growth, but have also redefined what's achievable in space research, offering capabilities that were once unimaginable. At the core of 3I/ATLAS's advancement is its AI-driven data processing system. Initially, the project relied on traditional computational methods to analyze data gathered from satellites and telescopes. However, as the volume of data increased exponentially, traditional systems became inadequate. AI has since taken center stage, enabling 3I/ATLAS to process petabytes of data in real time. Machine learning algorithms now autonomously identify patterns in the data, make predictions, and even propose new areas for research. For example, when 3I/ATLAS detects an anomaly, it can highlight potential areas of interest for researchers, drastically reducing the time needed for analysis and allowing for faster discoveries. Moreover, AI has revolutionized how 3I/ATLAS manages its vast network of satellites and telescopes. Machine learning models can autonomously adjust the settings of these instruments based on real-time data, ensuring that they capture the most relevant information without human intervention. This not only improves efficiency, but also increases the flexibility of the system, as it can easily adapt to unexpected conditions or anomalies. Alongside AI, quantum computing has emerged as another key enabler of 3I/ATLAS's growth. Quantum computing offers the potential to solve problems that are currently impossible for classical computers to handle. Although still in its early stages, the integration of quantum computing into 3I/ATLAS has already yielded remarkable results. For instance, quantum algorithms are being used to simulate complex cosmic phenomena, such as the behavior of black holes and dark matter, with unprecedented precision. These simulations are advancing our understanding of quantum physics and cosmology, and as quantum computing continues to evolve, it will likely enable 3I/ATLAS to tackle even more complex challenges. The synergy between AI and quantum computing is proving to be a powerful force, allowing 3I/ATLAS to process data, perform simulations, and make predictions more efficiently than ever. This combination of technologies is essential to the rapid expansion of the project, and as both continue to advance, they will play an even larger role in pushing 3I/ATLAS further into uncharted territory. Another crucial technology behind the expansion of 3I/ATLAS is advanced satellite engineering. The project has deployed a new generation of satellites equipped with cutting-edge sensors and communication systems that provide higher resolution imaging and more accurate data collection. These satellites are designed to operate autonomously, adjusting their positions and settings based on the data they receive. This autonomous capability allows 3i/ATLAS to conduct research without the need for constant human oversight, as the satellites can collaborate in real time, share data, and even decide what to observe next. This interconnected network of autonomous satellites forms the backbone of 3i/ATLAS, allowing it to cover vast areas of the sky and gather data from previously inaccessible regions of space. Additionally, next-generation telescopes with higher sensitivity and resolution are playing a vital role in the project's expansion. These telescopes capture images of distant galaxies, stars, and cosmic events with unparalleled detail, and when combined with AI and quantum computing, they enable 3i/ATLAS to uncover cosmic phenomena that were once beyond reach. Despite these technological advancements, the expansion of 3i/ATLAS raises important questions about its future trajectory. As the project continues to grow, it will face new challenges, particularly in managing the increasing complexity of its systems and ensuring data integrity. The integration of AI, quantum computing, autonomous satellites, and advanced telescopes introduces a unique set of challenges that must be addressed to maintain efficiency. The next frontier for 3i/ATLAS will likely involve integrating even more advanced technologies, such as neural networks for deeper pattern recognition and biocomputing systems that could revolutionize data storage and processing. As 3i/ATLAS continues to push the boundaries of technology, it may serve as a testing ground for innovations that could change how we approach research on Earth and in space. In conclusion, the technological ecosystem driving 3i/ATLAS's expansion is nothing short of extraordinary. The combination of AI, quantum computing, autonomous satellites, and advanced telescopes has created a system that is more powerful, efficient, and adaptable than anything previously seen. These technologies have not only fueled the project's growth, but have also set the stage for future breakthroughs that could transform our understanding of space, time, and the fundamental nature of reality. As 3i/ATLAS continues to evolve, the world will closely watch its progress, eager to see what new frontiers it will explore next. As 3i/ATLAS expands, it is sparking a new space race. But unlike the space races of the past, this competition is not about reaching distant planets or landing on the moon. The focus now is on the control of data, the ownership of knowledge, and harnessing the unknowns of space in ways that will reshape our understanding of the cosmos. In the past, the space race was driven by national pride, security concerns, and technological dominance, primarily between the United States and the Soviet Union. Today, the motivations for space exploration have shifted from territorial conquest to the management and exploitation of space-based data and technologies. Nations like the US, China, and Russia remain key players, but the competition now revolves around who controls access to this critical data and how it can be utilized for technological and economic advantage. 3i/ATLAS is at the center of this new space race. The project's ability to gather vast amounts of data, process it in real time, and share it across borders has elevated space exploration into an arena of global collaboration and competition. As 3i/ATLAS continues to generate more data, questions about ownership and access will become a source of geopolitical tension. The project's rapid growth has made it a critical resource, with nations and corporations vying for control over the insights it produces. The global nature of 3i/ATLAS means multiple nations, private companies, and academic institutions are intertwined in its success. Cooperation between governments and private industry is essential, and as private companies push to secure exclusive contracts and access to 3i/ATLAS's data, the stakes are higher than ever. The race is now defined by who can secure the rights to the data and use it to capitalize on new opportunities in space-based technologies. Countries with advanced space programs are investing heavily to remain competitive. The presence of private companies like SpaceX, Blue Origin, and smaller startups adds complexity to the race. These companies are no longer just supporting missions, they are becoming central players, holding exclusive contracts with government agencies or participating directly in groundbreaking missions. With this involvement, private companies have the opportunity to develop new technologies that could revolutionize industries like telecommunications, energy, transportation, and medicine. However, this growing corporate influence raises questions about the future of space exploration. As private corporations gain more control over space-based data, there is concern that the pursuit of profit could overshadow the pursuit of knowledge. The commercialization of space exploration could limit access to space's benefits, making it a commodity for a select few rather than a tool for the betterment of humanity. This shift in priorities calls for careful consideration to ensure space remains a resource for everyone, not just for profit-driven enterprises. Despite these concerns, the project is also fostering new relationships between nations that were once rivals in the space race. Countries investing heavily in 3/ATLAS are forming new alliances, transcending historical political divisions. This shift could mark a new era of space diplomacy, where global collaboration tackles large-scale challenges such as climate change, resource management, and disaster relief, all through the lens of space-based research. However, competition remains at the heart of this new space race. As 3/ATLAS expands, nations and corporations will continue to vie for exclusive rights to its data and technology. The project's capacity to generate real-time data and provide unprecedented knowledge could give certain countries and corporations a significant advantage in sectors ranging from communications, infrastructure to military applications. The stakes are higher than ever, with pressure mounting to maintain technological dominance in this high-stakes race. The growth of 3/ATLAS also emphasizes the increasing importance of space policy and international law. As access to space becomes an economic and security imperative, nations will need to develop treaties and agreements to regulate access to space, data sharing protocols, and the ethical use of space-based resources. Space law is becoming an essential field of study as countries prepare for a future in which space is no longer a matter of national pride but a critical element of global security. This emerging space race also raises philosophical questions about humanity's role in the universe. Will we treat space as an unlimited frontier for exploration and exploitation, or will we take a more ethical approach, carefully considering the long-term impacts of our actions? The answers to these questions will shape the trajectory of space exploration for generations to come. At the core of this new space race is a shift in perspective. It's no longer just about being the first to land on a distant planet. It's about mastering the vast data streams that will allow us to understand and navigate the cosmos. The race to control this information and leverage it for technological, economic, and geopolitical advantage is now as intense as any race to the moon. As 3/ATLAS continues to expand, the global space community will be watching closely. The future of this high-stakes race holds profound implications for the nations, companies, and individuals involved. The coming decades will bring dramatic changes to how we understand and interact with the universe, with 3/ATLAS at the center of this cosmic competition. The journey has only just begun, and its potential is boundless. As 3/ATLAS continues its rapid expansion, the future holds exciting possibilities that could significantly transform our understanding of space exploration. With its groundbreaking advancements, the project is poised to push the boundaries of technology, discovery, and global collaboration, shaping the way we view our place in the cosmos. The next logical step for 3/ATLAS will likely be the expansion of its observational capabilities. While the project already covers vast stretches of space with advanced satellites and telescopes, future technological developments could allow even deeper cosmic exploration. Continued progress in multispectral imaging, which captures light across various wavelengths, could enable 3/ATLAS to probe beyond the observable universe. This could unlock secrets once thought inaccessible, potentially uncovering evidence of other dimensions or parallel universes. In tandem with these advances, the development of real-time interstellar communication could revolutionize future space missions. If 3/ATLAS develops the ability to communicate instantly with distant spacecraft or research stations, it could enable data sharing across vast distances. Such a capability would drastically improve manned missions, allowing live data from Mars or even beyond the solar system to be received as quickly as data from Earth-based telescopes, bringing humanity closer to achieving sustainable space presence. Beyond expanding observational reach, 3I/ATLAS might integrate AI-driven discovery processes into space exploration. The project already leverages AI for data analysis, identifying cosmic anomalies human researchers might miss. In the future, AI could autonomously discover new celestial objects or forces, taking the lead in exploring space. This shift from human-guided to AI-driven discovery would mark a significant advancement in space research. Another exciting possibility is the development of self-sustaining space stations or research outposts, built using real-time data from 3I/ATLAS. These outposts could be located on celestial bodies such as Mars or Europa, with 3I/ATLAS providing the resource maps necessary for identifying viable locations. The potential for space mining, particularly for water ice or minerals from asteroids, could enable humanity to establish permanent settlements beyond Earth. This would represent a monumental leap forward in the colonization of space. Furthermore, the vast data collected by 3I/ATLAS is likely to drive the creation of space-based industries. With advancements in AI, quantum computing, and satellite technology, space tourism, interplanetary resource extraction, and space manufacturing could become viable industries within decades. 3I/ATLAS could also serve as a key infrastructure hub, providing the data and real-time feedback necessary to bring these industries to life. Perhaps the most profound impact of 3I/ATLAS's growth is its potential to redefine humanity's relationship with the cosmos. As the project uncovers more about the universe, it raises critical questions about existence, the origins of life, and our place in the universe. Could 3I/ATLAS provide evidence of extraterrestrial life, or reveal the true nature of consciousness? Could it suggest that our universe is part of a broader multiverse? These questions, though speculative, are becoming increasingly tangible with each new discovery. While the future of 3I/ATLAS is promising, it is not without challenges. As the project expands, managing its vast network of technologies and data will become increasingly complex. Ethical dilemmas surrounding the commercialization of space, the regulation of space resources, and the handling of massive data streams will only intensify. Who will control the data, and how will it be used? As the benefits of space research extend beyond a few nations or corporations, questions about access and control will become more urgent. The growth of 3I/ATLAS may also lead to geopolitical tensions as nations and private companies compete for space resources. A new era of space diplomacy could emerge, with countries needing to cooperate to govern space activities while competing for resources. The issue of who owns space data and resources will shape the next phase of humanity's journey into space. Ultimately, the future of 3I/ATLAS will not only be defined by the data it collects or the technologies it develops, but by how humanity chooses to use its discoveries. The project's continued growth promises unprecedented opportunities, but also raises new questions and challenges. As 3I/ATLAS expands the boundaries of space exploration, it will undoubtedly play a central role in shaping the future of technology, human advancement, and global collaboration. The journey into this new era of space exploration, driven by 3I/ATLAS, is just beginning. The future holds infinite possibilities, and with each step, humanity moves closer to unlocking the mysteries of the universe. Stay tuned as 3I/ATLAS continues to explore the vast, uncharted frontier of space and all the potential it holds. As 3I/ATLAS expands its reach into the cosmos, it presents not just opportunities but profound ethical dilemmas that will shape the future of space exploration. The project's rapid growth, its vast data streams, autonomous AI systems, and global collaborations raises pressing questions about privacy, data ownership, and the exploitation of space resources. As humanity ventures further into space, it is crucial to consider the ethical frameworks that will guide this new frontier. What is the cost of knowledge, and who decides how this knowledge is used? A key ethical issue is data ownership. With 3I/ATLAS capturing vast amounts of cosmic data, who owns this information? Is it the governments funding the project, the private companies supplying the technology, or the global community benefiting from the discoveries? As the project's data grows in value, The stakes around ownership will become higher. Will countries or corporations monopolize access to this resource? Or can we find ways to ensure the data benefits humanity as a whole? The ethics of data privacy in space research also presents significant concerns. While 3I/ATLAS focuses on astronomical data, the technologies used to collect and process this information may also be capable of monitoring Earth. In the future, could these systems be used to track terrestrial activities such as military movements or even private citizens? The potential for space-based surveillance raises important questions about the balance between scientific progress and individual privacy. Who will regulate these capabilities, and how can we ensure they are used responsibly? Another critical ethical question revolves around the exploitation of space resources. As 3I/ATLAS maps the cosmos, it will likely identify valuable resources such as minerals, metals, and water on asteroids, moons, and distant planets. While this could help alleviate resource shortages on Earth, it also brings the risk of space becoming a new domain for colonization and resource extraction. Should humanity claim ownership of these resources? And if so, who decides how they are used and who profits? The commercialization of space could trigger a new race, not just for exploration, but for control over extraterrestrial materials. As we explore these new opportunities, we must develop ethical frameworks to ensure we do not repeat past colonial mistakes. Space law will play an increasingly crucial role as 3I/ATLAS grows. The Outer Space Treaty of 1967 provides guidelines for space exploration, but it was established long before projects like 3I/ATLAS existed. As new technologies, such as AI-driven exploration and space mining, emerge, existing laws may be inadequate to address the challenges ahead. How will the international community adapt its legal frameworks to accommodate space commercialization and the competing interests of various stakeholders? Will space be governed by principles of shared exploration, or will it become more fragmented and competitive? The environmental impact of space exploration is another ethical concern. As we extract resources from space, we must consider the environmental cost of launching satellites, mining asteroids, and building space infrastructure. Can we balance the benefits of space exploration with the urgent need to address climate change and environmental degradation on Earth? Ensuring that space exploration does not harm our planet is a complex ethical challenge that cannot be overlooked. The distribution of the benefits of space research is also central to the ethical debate. Space exploration has traditionally been driven by government and military interests, with increasing involvement from private companies. As 3I/ATLAS grows, will the benefits of its discoveries be shared equitably across the globe, or will they be concentrated in the hands of a few powerful nations or corporations? The global community must ensure that the fruits of space exploration, new technologies, cosmic resources are accessible to all, not just those with the most political or economic power. Another pressing ethical question is the role of AI in space exploration. As 3I/ATLAS increasingly relies on AI for data processing and decision-making, we must ask, what ethical guidelines should govern autonomous systems? If an AI system alters the course of a satellite or selects a cosmic event to observe, who is responsible for that decision? How can we ensure that AI operates ethically without unintended bias or harmful consequences? As AI becomes more integrated into space research, strong ethical frameworks must be established to prevent adverse outcomes. As 3I/ATLAS continues to expand, these ethical challenges will only grow in importance. Our ability to explore space brings significant responsibilities. The decisions we make today about data ownership, the use of space resources, and the regulation of space technologies will shape the future of space exploration. The questions we face are not just scientific, they are moral and philosophical. What kind of future do we want to create in space, and how can we ensure that our actions today contribute to a just and sustainable future for all? The ethical challenges posed by 3I/ATLAS require thoughtful consideration from governments, corporations, and citizens. As we continue to explore the cosmos, we must ensure that our actions are guided by fairness, responsibility, and stewardship. Addressing these ethical dilemmas will help ensure that space exploration serves the greater good of humanity. The decisions we make now will have far-reaching consequences, and how we navigate these challenges will define the future of space for generations to come. As 3I/ATLAS continues its rapid expansion, its impact will reach far beyond the current generation of researchers and explorers, shaping future space exploration, technological innovation, global collaboration, and human philosophy. The legacy of this groundbreaking project is already taking form, and it promises to influence humanity for generations, transforming our place not only on Earth, but in the cosmos. One of the most immediate legacies of 3I/ATLAS is its technological advancements. The tools and systems developed for the project push the boundaries of artificial intelligence, quantum computing, space engineering, and data processing. These innovations extend beyond space exploration and have far-reaching applications across industries on Earth. For instance, AI systems designed for cosmic data processing are now enhancing medical diagnostics, improving financial modeling, and even assisting in climate change predictions. The technological advancements driven by 3I/ATLAS create a virtuous cycle where progress in space exploration accelerates improvements in other sectors, which, in turn, benefit the scientific community. The project's global impact also contributes to its enduring legacy. By fostering international collaboration, 3I/ATLAS is paving the way for a new era of space diplomacy. In a world often divided by political and economic lines, the project serves as a model for cooperation, showing what can be achieved when countries, corporations, and scientific institutions unite toward a common goal. This collaborative model could serve as a framework not just for space exploration, but for tackling other global challenges like climate change, public health, and resource management. 3I/ATLAS demonstrates that when humanity comes together, we can overcome even the most monumental challenges. 3I/ATLAS will also leave a lasting intellectual legacy. The discoveries made by the project will likely redefine our understanding of the universe. As new cosmic phenomena are uncovered, the foundations of astronomy, physics, and cosmology will be challenged and refined. The knowledge gained will serve as a springboard for future generations of scientists and philosophers, driving the next wave of discovery and expanding the boundaries of human understanding. For those who follow, 3I/ATLAS will be remembered as the project that redefined the limits of human knowledge. Beyond technology and science, 3I/ATLAS will also leave a profound cultural legacy. As the project continues to capture the imagination of people worldwide, it has the potential to inspire new generations of innovators and explorers. Much like the Apollo missions inspired a generation of scientists and engineers, 3I/ATLAS could ignite a new space renaissance, influencing art, literature, technology, and education. The idea that humanity can explore the farthest reaches of space and make sense of cosmic mysteries will become woven into society, inspiring future generations to dream bigger and push further than ever before. As 3I/ATLAS continues to shape the future, it will spark philosophical debates about humanity's role in the cosmos. What does it mean to be a spacefaring species? What responsibilities come with the ability to explore and exploit space? The discoveries made by the project may lead to profound reflections on existence, extraterrestrial life, and humanity's place in the universe. The legacy of 3I/ATLAS will not only be defined by the data it collects, but by the philosophical questions it raises and the conversations it inspires. The project will also serve as a foundation for future space missions, whether through developing new space habitats, missions to distant moons or planets, or the search for extraterrestrial life. 3I/ATLAS will be the blueprint for the next generation of explorers. The project may inspire a new era of space colonization, with humanity establishing a presence on distant planets and moons, securing our place as a multiplanetary species. The education system will also feel the influence of 3I/ATLAS. As new discoveries unfold and technologies emerge, the curriculum for future scientists, engineers, and mathematicians will be shaped by the innovations sparked by the project. Students will study 3I/ATLAS not only as a scientific achievement, but also as a testament to how collaboration and technology can overcome seemingly insurmountable challenges. The next generation will build on the groundwork laid by 3I/ATLAS, taking space exploration and our understanding of the universe into new realms. The most enduring legacy of 3I/ATLAS will be the sense of possibility it instills in future generations. The project's scale, complexity, and successes will remind humanity of its capacity to achieve the extraordinary. It will demonstrate that when we unite to tackle the unknown and apply our most advanced technologies to the biggest challenges, there is no limit to what we can achieve. The dream of exploring the cosmos will no longer be a distant ambition, but a collective goal shared by all of humanity. Looking ahead, the legacy of 3I/ATLAS will continue to inspire and guide the future of space exploration. With each new discovery, technological leap, and philosophical question raised, 3I/ATLAS will shape the course of human progress for centuries to come. Its journey is far from over, and its legacy has only just begun. As 3I/ATLAS expands, humanity is poised on the edge of a new chapter in space exploration. The dream of reaching the stars is becoming a tangible reality, one that promises to challenge our understanding of existence and our place in the universe. But what lies ahead? What mysteries and opportunities will emerge as we push the boundaries of space exploration? Although 3I/ATLAS has already achieved remarkable feats, the journey is just beginning. The project's reach is set to expand further, exploring deeper into the cosmos and seeking answers to questions that have long puzzled humanity. We're on the verge of uncovering cosmic truths that could revolutionize science and human understanding, from dark matter and black holes to the origins of the universe itself. In the near future, 3I/ATLAS will likely focus on more immersive exploration of distant space phenomena. With advanced telescopes and AI-powered systems, the project will map regions of the universe with unprecedented precision. It's not just about observing distant galaxies, it's about understanding the fundamental forces that govern the cosmos. Gravitational waves and the cosmic microwave background will become regular subjects of study, offering insights into the early moments of the universe and the nature of space-time. As the scope of 3I/ATLAS grows, we may witness the rise of autonomous interstellar missions. The technology to send probes to distant stars is no longer a distant dream but a feasible goal. This could lead to discovering new forms of energy or matter that we cannot yet imagine, or even uncovering life beyond Earth. The potential to gain knowledge from other galaxies could dramatically expand our understanding of the universe. However, the most profound questions may not be about the cosmos itself, but about humanity. Space exploration is a journey of self-discovery, one that forces us to confront existential questions. Why are we here? How did life begin? What is the ultimate fate of the universe? These questions are not only scientific but philosophical, and they challenge us to rethink our place in the universe. The growth of 3I/ATLAS extends beyond science and technology. It is shaping humanity's future. As we uncover the mysteries of space, we must also confront our role in the cosmos. The more we learn, the more we realize the fragility and insignificance of human existence in the grand scheme of things. Yet the pursuit of space exploration also holds the potential to unite humanity. It offers a vision of cooperation, where nations and corporations work together not for individual gain, but for the greater good of all. As we move forward, it's crucial to recognize that space exploration is a collective effort. It is not just about the nations and corporations driving the project. It is about the future generations who will inherit the knowledge and technologies we create. Today's children will be tomorrow's astronauts, engineers, and scientists, building on the work done by 3I/ATLAS. The decisions we make today will shape the direction of space exploration for future generations. The final frontier is no longer a distant concept, it is within our reach. With 3I/ATLAS leading the way, we are on the brink of unlocking new dimensions of understanding. Each new discovery brings us closer to answering fundamental questions about the universe and our place within it. However, the ultimate goal of space exploration is not just to discover new worlds, but to enrich our own. Every advancement in technology and every breakthrough brings us closer to understanding what it means to be human. The true final frontier may not lie in the farthest reaches of space, but in exploring our collective potential, our ability to come together as a species and dream beyond the boundaries of Earth. As 3I/ATLAS continues to unfold, the journey is just beginning. The discoveries ahead may change everything we know about the universe and ourselves. The future is vast, unknown, and filled with possibilities. With 3I/ATLAS, the journey is ours to shape. As 3I/ATLAS progresses, it becomes clear that this project represents more than just a leap in space exploration. It embodies humanity's collective curiosity, innovation, and determination to explore the unknown. This journey is not only about the stars, but about ourselves and our place in the universe. Space exploration has always been about knowledge as a universal pursuit. Over the centuries, from Earth's first explorations to the moon landings, our curiosity has known no bounds. What sets 3I/ATLAS apart is its global nature. This is no longer a project of a few nations, but one driven by international collaboration. The legacy of 3I/ATLAS will be its demonstration that the most ambitious scientific endeavours can unite humanity, transcending borders and divisions. It's a testament to what we can achieve when we collaborate for a shared purpose. The expansion of 3I/ATLAS also signifies a shift in how we understand time and space. What was once a limitless frontier is now becoming a known entity. As we explore deeper into the cosmos, we challenge our previous assumptions, revise our models, and refine our understanding of the forces that shape reality. From the origin of the universe to dark energy, 3I/ATLAS is pushing us to confront the mysteries of time itself. It serves as a humbling reminder that, even as we reach for the stars, we are still searching for answers to questions that have persisted for millennia. On a philosophical level, the impact of 3I/ATLAS will reshape how we view humanity's place in the universe. For centuries, we believed Earth was the center of existence. Now, as we observe galaxies billions of years old and send probes to distant worlds, we see how small and transient our planet is in the cosmic scale. Yet this realization can bring empowerment rather than despair. Understanding our connection to something so vast can instill purpose and remind us that human existence is part of a grand, interconnected narrative of cosmic events. This evolving perspective also reshapes our understanding of life. The question of whether we are alone in the universe has intrigued humanity for centuries. With the capabilities of 3I/ATLAS, we are on the brink of answering that question. Every new data point from distant stars and planets brings us closer to discovering whether life exists elsewhere. What would it mean if we found life beyond Earth? Such a discovery could challenge long-held beliefs, reshape religions, and open new doors for interspecies understanding. These questions, once speculative, are becoming increasingly tangible as 3I/ATLAS expands its reach. 3I/ATLAS's legacy is also poised to redefine our vision for the future. In a world facing global challenges like climate change, political instability, and economic uncertainty, space exploration offers a hopeful vision. The technological breakthroughs and global cooperation fostered by 3I/ATLAS present a model for tackling daunting challenges, coming together, pushing beyond limitations, and embracing the unknown with purpose. Space exploration is not just about expanding physical boundaries, it's about expanding our capacity for innovation, collaboration, and resilience. Ultimately, 3I/ATLAS's significance extends beyond the data and discoveries it generates. It is a reflection of humanity's potential. It shows us what we can achieve when we set aside differences and unite toward a common goal. It highlights the infinite possibilities ahead, not just in space, but in the way we choose to shape our future on Earth. As we reflect on the journey of 3I/ATLAS, it's clear that its influence will go beyond space exploration. It will change how we view the world, the universe, and ourselves. The questions it raises, the discoveries it uncovers, and the possibilities it opens will shape the world for generations to come. As we continue to explore the vast unknown, we must keep our focus not just on the stars, but on the lessons 3I/ATLAS teaches us: the importance of collaboration, the value of knowledge, and the belief that humanity's greatest achievements are still ahead of us. The journey of 3I/ATLAS has just begun, but its impact will echo throughout history. It will guide future generations toward a future we can only begin to imagine. Its legacy will not just be defined by the data it collects, or the technologies it develops, but by the indomitable spirit of exploration it embodies. This spirit will continue to inspire the dreams and ambitions of those who follow in its wake. As 3I/ATLAS progresses, it becomes clear that this project is not just a leap in space exploration, but a testament to humanity's spirit of exploration. It represents the culmination of centuries of curiosity, ambition, and the desire to understand the universe. The project is more than a scientific venture. It reflects the collective drive of humanity to explore beyond our earthly bounds and answer questions that have puzzled us for millennia. The human connection to space exploration is deep and profound. It transcends borders, ideologies, and cultures. While the technology powering 3I/ATLAS is complex, it is the people, the researchers, engineers, scientists, and visionaries who breathe life into the project. Each milestone achieved represents a collective effort, one that reflects our shared desire for a better understanding of the cosmos and, by extension, our existence. The success of 3I/ATLAS is a testament to the power of collaboration. The project has drawn together scientists, engineers, and innovators from across the globe, demonstrating that no single nation or institution could address the challenges alone. From governmental space agencies to private tech companies, universities, and research labs, 3I/ATLAS has become a model for global cooperation. This collaborative effort is not just about pooling resources or expertise, it's about building a shared vision of the future where humanity works together to explore the unknown. The expansion of 3I/ATLAS also highlights humanity's unrelenting curiosity, a trait that has driven exploration since the beginning of civilization. From early observations of the night sky to space missions like the moon landings, humanity has always sought to understand what lies beyond the immediate horizon. In this context, 3I/ATLAS is part of a long tradition of human exploration, enabling us to observe and interact with the cosmos in ways previously unimaginable. Beyond scientific advancements, the true human connection to 3I/ATLAS lies in the sense of wonder it inspires. Each new discovery, from the detection of new cosmic phenomena to the mapping of distant stars, invites us all to share in the excitement. These moments are not just milestones for scientists, they ignite imagination and hope, driving people around the world to dream of a future where humanity continues to explore, discover, and grow. This sense of wonder extends beyond the research community. The discoveries made by 3I/ATLAS are not just for scientists, they are part of a larger human story, accessible to anyone with curiosity. Through public outreach, educational initiatives, and global collaborations, 3I/ATLAS has brought space exploration to a broader audience, fostering a collective sense of curiosity that transcends traditional boundaries. The emotional connection to space is a legacy passed down through generations. As a species, we've always gazed at the stars, asking questions about our origins, destiny, and the possibility of life beyond Earth. 3I/ATLAS taps into this primal urge, providing the tools to answer these questions and reminding us that we are part of something much larger than ourselves. This connection is not just intellectual, it is deeply emotional, rooted in the awe we feel when we look up at the night sky and the excitement of discovery. Moreover, 3I/ATLAS's exploration of space deepens our connection to Earth. As we learn more about the cosmos, we are reminded of the delicate balance that sustains life on our planet. The vast, inhospitable reaches of space offer a stark contrast to the fragile, beautiful world we call home. The pursuit of space exploration forces us to reconsider how we treat our planet, manage resources, and live in harmony with the environment. Space serves as a reminder of the preciousness of Earth and our responsibility to protect it. As 3I/ATLAS's discoveries continue to unfold, the human connection to the cosmos will only grow stronger. The project will not only drive technological advancements, but will also shape our collective identity. It will inspire future generations to look up at the stars just as our ancestors did, with the knowledge that we are part of the great story of the universe. In the end, 3I/ATLAS is more than a scientific project. It is a celebration of humanity's potential, an exploration of our collective dreams, and a reminder of the boundless possibilities that await us. The journey may be long and the challenges great, but the human spirit, the same spirit that has driven explorers throughout history, will continue to push us forward into the unknown. The journey of 3I/ATLAS is just beginning. As it unfolds, we'll be reminded that our connection to the universe is not just about the data we collect or the technologies we build. It is about the stories we tell, the questions we ask, and the wonder that continues to inspire us all. Through 3I/ATLAS, humanity will continue to explore, dream, and reach for the stars. As 3I/ATLAS progresses, the path ahead is filled with both immense potential and significant challenges. Every breakthrough in space exploration brings with it obstacles that will require innovation, resilience, and careful planning. As the project pushes further into the cosmos, the challenges of scaling 3I/ATLAS and maintaining its trajectory will be some of its most critical tests. One of the most pressing issues is the sheer volume of data 3I/ATLAS generates. With its growing network of satellites, telescopes, and research stations, the project collects vast amounts of cosmic data. Managing and processing this information efficiently becomes increasingly complex. The real-time processing of petabytes of data is a remarkable achievement, but presents immense computational demands. As AI systems and quantum computing technologies evolve to handle these demands, the challenge lies not only in managing the data but ensuring its integrity, accuracy, and security as the system scales. Moreover, as the data expands, interpreting it will become more difficult, requiring new tools and methods to analyze and ensure the discoveries are meaningful and scientifically relevant. Ethical and legal considerations are also critical as 3I/ATLAS grows. The ability to collect high-resolution, real-time data from across the universe raises questions about privacy, data ownership, and space governance. While most of the data focuses on cosmic phenomena, the technology could potentially be adapted for monitoring Earth-bound activities. This raises concerns about the possibility of space-based surveillance and the misuse of this technology by powerful nations or corporations for geopolitical or commercial purposes. Furthermore, the governance of space will need to evolve. As private companies become more involved in space exploration and resource extraction, new international agreements will be required to ensure that space remains a shared resource, not a contested frontier. Issues surrounding data ownership and the extraction of space resources must be addressed by international bodies to prevent conflicts and ensure equitable access for all. Sustainability and environmental concerns are also pressing as 3I/ATLAS expands. The environmental cost of launching rockets, maintaining satellites, and constructing infrastructure is substantial. As the project grows, these costs could become unsustainable if not managed properly. Space debris, in particular, is a growing concern. The more satellites launched to support 3I/ATLAS, the higher the risk of collisions and debris accumulation. This can endanger both space infrastructure and future missions. Therefore, innovative approaches to sustainability, including space debris management and satellite recycling technologies, will be crucial. Additionally, as humanity looks toward the future, mining asteroids and extracting resources from distant moons, new ethical and environmental concerns will emerge. How do we balance the potential of these resources with the need to protect the integrity of space itself? This question will become more pressing as 3I/ATLAS and similar projects pave the way for space resource extraction. The human element remains at the core of 3I/ATLAS's success. While the project is technological, it is the scientists, engineers, and researchers who drive it forward. As 3I/ATLAS grows, attracting and retaining top talent will be essential. With space exploration becoming increasingly specialized, future generations of scientists and engineers must be trained to tackle the growing complexity of the field. Additionally, the mental and emotional well-being of those involved in the project is a crucial consideration. The demands of such a large-scale endeavor, long hours, high stress, and tight deadlines, can take a toll on individuals. It will be essential to create systems of support to ensure the well-being of those contributing to the project's success. Public engagement and education are also key to 3I/ATLAS's future. As the project continues to make groundbreaking discoveries, ensuring that these findings are communicated effectively to the public will be essential. Space exploration has the power to inspire and spark curiosity across the globe. Public engagement is not only about making discoveries accessible, but also about fostering a new generation of explorers, researchers, and thinkers. The future of space exploration depends on the imagination and curiosity of young people, who will carry forward the torch of exploration and innovation. Making space exploration relatable, exciting, and accessible is crucial in inspiring future generations to pursue careers in science and technology. The road ahead for 3I/ATLAS is filled with challenges, but these obstacles are precisely what will push humanity further in its exploration of the cosmos. The data overload, ethical considerations, environmental concerns, and the human element all present complex issues, but with innovation, collaboration, and resilience, these challenges can be overcome. The next phase of 3I/ATLAS will be about addressing these hurdles and laying the groundwork for future generations to explore the unknown. The future of 3I/ATLAS is uncharted, but through collective effort, it will continue to push the boundaries of space exploration. The journey has just begun, and with each step forward, humanity will continue its quest to uncover the mysteries of the universe. Stay with us as we embark on this exciting journey into the stars, one discovery at a time. As 3I/ATLAS progresses, it becomes clear that the project's significance stretches far beyond its technological achievements and immediate breakthroughs. The questions it raises, the challenges it presents, and the future it shapes are not confined to this project alone. 3I/ATLAS is part of a larger shift in human exploration, and its legacy will continue to evolve as the next generation of space initiatives begins to take shape. The success of 3I/ATLAS has set the stage for a new era of space exploration, one that promises to expand our reach farther than ever before. The foundations it has laid are just the beginning, and as its discoveries continue to reverberate across the scientific community, they will pave the way for even more ambitious missions. However, as 3I/ATLAS grows and evolves, so too must our vision for the future of space. While 3I/ATLAS has already made significant strides in understanding the outer reaches of our universe, there's still much more to explore. The project has set its sights on uncharted areas such as dark matter, cosmic radiation, and gravitational waves. But these are only the beginning. As our understanding deepens and technology advances, new frontiers will open up. The next logical step in space exploration, fueled by 3I/ATLAS's progress, is the development of interstellar probes capable of travelling beyond our solar system. Although current technologies are not yet designed for long-range exploration, advances driven by 3I/ATLAS could bring us closer to missions targeting exoplanets in distant star systems. For example, sending a probe to the Alpha Centauri system could reveal new data on planets that may harbour life or offer insights into cosmic evolution. This could transform the way we approach deep space exploration and lead to new technologies for interstellar travel. At the same time, 3I/ATLAS is laying the groundwork for human exploration of distant planets. In the coming decades, we may see humans travelling to Mars, Venus, or even the moons of Jupiter and Saturn. The advanced AI, life support systems, and autonomous spacecraft developed by 3I/ATLAS could enable these ambitious missions, allowing us to establish a permanent presence beyond Earth. Space stations, once considered distant possibilities, may soon become stepping stones to even farther destinations. In addition to pushing the boundaries of exploration, 3I/ATLAS has the potential to catalyse a global spacefaring society. The project could inspire nations and corporations to collaborate on space resources, research outposts, and the protection of the cosmos. As space exploration advances, international treaties and agreements will become necessary to manage resources, govern exploration, and address ethical concerns. Space law will need to evolve to ensure equitable access, peaceful exploration, and the responsible use of space. New regulations will be required to address space resource extraction, space debris management, and the protection of celestial bodies. International bodies like the United Nations will likely play a growing role in shaping space governance to prevent conflicts and ensure that space remains a shared resource for all. The rise of space-based industries such as asteroid mining, space tourism, and space-based solar power will also drive the development of international trade agreements. Space resources, including rare minerals and water ice, will likely fuel the future space economy. Private companies, once limited to Earth-based industries, will now seek to capitalize on space's untapped resources, giving rise to a new space economy. This integration of space exploration into the global economy will shape not only technological progress, but also cultural, societal, and geopolitical relations, making space an integral part of the human experience. As space exploration advances, humanity will confront deeper philosophical and existential questions about its place in the universe. The discovery of life beyond Earth, whether microbial or intelligent, will challenge our understanding of life and our role in the cosmos. Such discoveries could reshape our beliefs and spark a new era of interspecies understanding. These profound questions are no longer speculative, they are becoming increasingly tangible as 3I/ATLAS collects data from the farthest reaches of the cosmos. Moreover, 3I/ATLAS's exploration of the universe may lead to new insights about the origins of the cosmos itself. Could dark energy or dark matter help us understand the birth of the universe or the forces that govern it? Could the fundamental nature of time be revealed through the study of cosmic phenomena? These are existential questions that push the limits of science, offering profound reflections on reality, existence, and the universe. The legacy of 3I/ATLAS will not only be defined by its scientific and technological contributions, but also by the philosophical journey it takes humanity on. As we venture further into space, we will not only redefine our place in the cosmos, but also expand the boundaries of human thought and understanding. The discoveries of 3I/ATLAS will transform how we view the stars and ourselves. The journey of 3I/ATLAS is far from over, and its future chapters will bring even more groundbreaking discoveries. As the project continues to unfold, it will drive technological advancements, spark global collaboration, and inspire new generations of dreamers and explorers. The legacy of 3I/ATLAS will shape humanity's path toward the stars, a journey marked by exploration, discovery, and transformation. The stars await, and humanity is ready to meet them. The final frontier is not just a destination, it's a path we've already begun to travel one step at a time. As we witness the ongoing advancements of 3I/ATLAS, it becomes clear that this project represents far more than just the culmination of technological achievements and space exploration milestones. Its significance lies in the future it promises, one filled with endless possibilities that will shape humanity's journey for generations to come. While 3I/ATLAS continues to break new ground in our understanding of the cosmos, its true legacy will be how it opens the door to deeper exploration and innovation. 3I/ATLAS is not merely a destination, it is a launch pad for what lies ahead. The technologies and discoveries born from this project are only the beginning. As its capabilities evolve, the challenges it faces will lead to even more profound questions, propelling humanity forward into new realms of knowledge. The next phase of exploration will not only build on 3I/ATLAS's successes, but will set the stage for breakthroughs that we can scarcely imagine today. One of the most exciting developments on the horizon is the rise of next-generation AI systems that will extend the reach of 3I/ATLAS even further. Today's AI models have already transformed space exploration, enabling faster data processing and autonomous decision-making. However, the evolution of artificial general intelligence (AGI), machines capable of performing tasks traditionally reserved for humans, could take 3I/ATLAS's capabilities to the next level. AGI systems might not only assist researchers, but could become autonomous agents capable of directing entire space missions. These systems would analyze massive amounts of data, identify new patterns, generate hypotheses, and even develop new scientific theories without human intervention. Such advancements could accelerate our understanding of the universe, enabling us to make sense of complex phenomena like dark matter and the origins of the universe. Alongside AI, quantum space travel holds tremendous potential for the future. Traditional space exploration is limited by the vast distances between stars and the capabilities of current propulsion systems. However, breakthroughs in quantum physics could offer solutions that radically change how we think about space travel. Quantum entanglement, for example, could enable instantaneous communication across the cosmos, or even teleportation of information and objects. While we are far from achieving teleportation, advancements in quantum computing and networking could lead to new propulsion technologies, allowing spacecraft to travel vast distances in a fraction of the time it currently takes. This would not only enhance space exploration, but also open the door to interstellar travel, enabling humanity to explore exoplanets and potentially colonize other star systems. In addition to advancements in AI and propulsion, harnessing space-based energy will be crucial for humanity's future. The sun provides an almost limitless source of energy, and space-based solar panels could capture this energy without the interference of Earth's atmosphere. This clean, renewable energy could be transmitted back to Earth, helping to address global energy shortages and powering future colonies on the Moon or Mars. With 3I/ATLAS leading the way, space-based energy could become a core part of global infrastructure, helping humanity achieve sustainability both on Earth and in space. The potential for space colonization is also a central theme for the future of 3I/ATLAS. The technologies developed by the project, advanced life support systems, autonomous habitats, and sustainable energy solutions, will provide the foundation for human colonies on the Moon, Mars, and beyond. The Moon, as Earth's nearest neighbour, will likely be the first target for permanent human presence. Lunar bases could serve as research outposts, resource hubs, and testing grounds for technologies required for interplanetary colonization. Following the Moon, Mars offers a more hospitable environment for human settlement, with 3I/ATLAS's data playing a critical role in mapping the planet's surface, identifying resources, and monitoring environmental conditions. These advances will enable the establishment of self-sustaining colonies on Mars, using local resources to support life. Beyond Mars, the dream of interstellar colonization may become a reality. With advancements in quantum propulsion and AI-guided navigation, humanity could eventually target star systems such as Proxima Centauri. Probes and AI-driven spacecraft could explore exoplanets in habitable zones, potentially discovering new forms of life and expanding our understanding of the cosmos. The dream of interstellar travel, once a distant fantasy, may no longer seem impossible. As space exploration expands, humanity will also face deep philosophical and existential questions about our place in the universe. The discovery of life beyond Earth, whether microbial or intelligent, could challenge our most fundamental beliefs about life, the universe, and our role within it. These discoveries would not only have scientific implications, but could force us to rethink our understanding of intelligence, consciousness, and human purpose. Furthermore, 3I/ATLAS's exploration of the universe will continue to challenge the nature of time, dark matter, and dark energy, driving humanity to confront the very building blocks of existence. The drive to explore has always been an essential part of the human spirit. 3I/ATLAS embodies this drive, pushing the boundaries of what we can achieve while inspiring future generations to explore the unknown. As the project unfolds, it not only paves the way for scientific and technological advancements, but also reshapes our collective identity and our understanding of what it means to be human. Looking ahead, the future of 3I/ATLAS and space exploration is filled with limitless possibilities. With each new discovery, humanity will continue to unlock the mysteries of the universe, moving closer to understanding our place in it. The journey is just beginning, and the best is yet to come. The stars await, and humanity is ready to meet them. As 3I/ATLAS sets the foundation for future space exploration, it's clear that its significance stretches beyond its immediate breakthroughs and technological advances. The project is not just about scientific discovery, it represents a launchpad for humanity's journey into the cosmos. The path we're paving today will shape the future, as we seek to unlock the potential of space and its vast resources. While the data gathered by 3I/ATLAS excites the scientific community, the real challenge is how we build upon these discoveries to create a sustainable, thriving, spacefaring civilization. One of the most immediate challenges humanity will face as space exploration moves beyond Earth is the establishment of permanent habitats beyond our planet. 3I/ATLAS plays a pivotal role in identifying ideal locations for these habitats and the materials required for their construction. The Moon and Mars are the primary targets for the first wave of colonization, but each presents unique challenges. The Moon's proximity to Earth offers clear advantages for short-term missions and technology testing. However, its extreme temperatures, minimal atmosphere, and exposure to cosmic radiation pose serious challenges for habitat construction. Lunar habitats may be built through modular systems, potentially 3D printed using lunar regolith to protect settlers from harsh conditions. Mars, with its Earth-like day-night cycle and potential for resource utilization, presents a more hospitable environment. However, its thin carbon dioxide-rich atmosphere and sparse water require solutions for sustainability. Advanced bioreactors could convert CO2 into oxygen, while water ice could be extracted from Mars' subsurface to support life. The long-term goal is to create self-sustaining colonies that rely on in-situ resources to maintain life. This will require advanced technologies for recycling air, water, waste, and producing food and materials. 3I/ATLAS plays a critical role in identifying key resources on celestial bodies that could be mined or used, such as water for fuel, minerals for building, and solar energy. As space construction technology and resource utilization improve, the vision of self-sustaining colonies becomes more feasible. These colonies will not only serve as scientific research hubs, but also as the first steps toward creating off-Earth economies. As space exploration progresses, private enterprise will play an increasingly important role in the space economy. 3I/ATLAS, by providing a wealth of data, will enable private companies to harness space resources for commercial purposes. The space industry will evolve from a research-driven venture to a fully fledged space economy, with key sectors such as space tourism, asteroid mining, space-based solar power, and interplanetary transportation driving its growth. Space tourism, though still in its infancy, has the potential to become a multi-billion-dollar industry. Suborbital flights and space hotels could become accessible to the public, creating new economic opportunities. Additionally, 3I/ATLAS's data will provide invaluable insights for companies focused on asteroid mining, where rare minerals like platinum and gold can be extracted. Space-based solar power also holds immense promise, enabling us to harness solar energy without atmospheric interference. Solar arrays on the Moon or Mars could revolutionize energy systems, providing power not only for colonies but also beamed back to Earth. However, the rapid commercialization of space presents important regulatory challenges. Space will no longer be a domain for scientific research alone. It will become a shared space where nations, corporations, and individuals have interests. The challenge will be balancing access to space resources with the responsibility to protect the environment of other planets and moons. International cooperation will be essential in creating regulations to manage space resources, prevent space debris accumulation, and ensure peaceful exploration. Public engagement and education will also be critical to the future of space exploration. The knowledge gained from 3I/ATLAS will help shape the next generation of scientists, engineers, and innovators. Education systems must evolve to meet the demands of the new space age, focusing on interdisciplinary fields like space science, AI, quantum physics, and resource management. In addition to education, public outreach initiatives such as interactive platforms, virtual experiences, and educational programs will help make space exploration accessible to everyone. This engagement will inspire a new generation of explorers and ensure that space remains a shared endeavour. As humanity continues to explore the unknown, we will face challenges that are difficult to predict. New technologies, unforeseen obstacles, and discoveries that challenge our understanding of physics and reality will arise. Yet, it is in overcoming these challenges that the true value of space exploration lies. The ultimate question humanity will confront is not just how far we can travel into the cosmos, but how we will adapt and evolve as we encounter new worlds, technologies, and possibilities. Space exploration is not only about discovering new realms, but about redefining humanity's role in the universe. 3I/ATLAS's journey is a reflection of humanity's unyielding drive to explore, understand, and transcend. With every discovery and challenge, it will continue to shape the trajectory of our future in space. The legacy of 3I/ATLAS will not just be the data it collects or the technologies it develops, but the indomitable spirit of exploration that it embodies. The journey into the stars is just beginning, and with each step humanity moves closer to realizing its potential in the vast expanse of the cosmos. As 3I/ATLAS continues to unfold, it will inspire new generations of dreamers and explorers, guiding humanity as it ventures into the stars. The path we take today will shape the future of space exploration for generations to come. As 3I/ATLAS continues to unfold, its impact on space exploration becomes ever more apparent. While the project has already achieved significant breakthroughs, the journey ahead promises even greater possibilities. The challenges and opportunities presented by 3I/ATLAS will not only shape the future of space science, but also redefine humanity's identity, pushing the boundaries of technology, knowledge, and our place in the universe. Humanity's ambition to expand beyond Earth is becoming increasingly tangible. With 3I/ATLAS providing valuable data, the infrastructure for future space colonies is actively being developed. The vision of permanent settlements on the Moon, Mars, or moons of Jupiter is no longer a distant dream, but a realistic goal driven by advancements in life support systems, sustainable energy, and resource utilization. Mars, as the most likely candidate for colonization, offers both challenges and opportunities. Its harsh environment, with extreme temperatures, a thin atmosphere, and low gravity, presents hurdles, but it also holds vital resources, such as water ice and minerals, that could sustain life. Future generations of space pioneers will rely on 3I/ATLAS's cosmic data to identify key sites for habitat construction and resource extraction, paving the way for self-sustaining colonies. As space technologies continue to evolve, new frontiers will open not just for exploration, but for creating new ways of life. These endeavors will not only expand human horizons, but also provide solutions to Earth's pressing challenges, including overpopulation, resource depletion, and climate change. The Moon, with its proximity to Earth, is expected to be the first site for permanent human presence, serving as a research hub and a testing ground for technologies needed on more distant planets. Meanwhile, Mars will likely become the next major target, offering a more hospitable environment with its Earth-like day-night cycle. The knowledge gained from 3I/ATLAS will help map the planet's surface, identify resources, and monitor environmental changes, enabling sustainable human settlements. The exploration of space will also lead to ambitious interstellar travel. As technology advances, space missions targeting star systems beyond our solar system may become possible. Quantum propulsion, AI navigation, and other breakthroughs could transform interstellar travel from science fiction to reality. 3I/ATLAS will play a crucial role in guiding humanity's first steps beyond the solar system, providing the data needed to navigate these uncharted territories. The potential to discover habitable exoplanets, or even life beyond Earth, could radically change our understanding of the cosmos, offering new homes for future generations. Artificial intelligence will remain central to this future. Today's AI systems already help analyze vast amounts of data and manage space systems, but the future may see AI evolve into more autonomous roles in space exploration. Artificial General Intelligence, AGI, capable of performing any intellectual task that humans could lead missions independently. These systems could autonomously gather data, make real-time decisions, and even develop new scientific theories based on the information they collect. Such advancements could accelerate the pace of discovery and exploration, enabling AI-powered spacecraft to explore galaxies, star clusters, and black holes, sending back data that fundamentally alters our understanding of space, time, and the laws of physics. As space exploration advances, so will the space economy. The commercialization of space resources such as asteroid mining and space-based solar power will play a critical role in the future sustainability of space exploration and Earth's economy. 3I/ATLAS's ability to provide valuable data on space resources will empower private companies to harness these resources for commercial purposes, driving the growth of a multi-trillion-dollar space industry. This expansion of space-based industries, along with space tourism, mining, and energy generation, will require new regulations to ensure that space resources are utilized responsibly and equitably. Ensuring that space remains a peaceful and sustainable domain will require international cooperation and new governance frameworks, with the lessons learned from 3I/ATLAS shaping the policies that govern the space economy. As humanity ventures further into space, ethical questions will become even more pressing. What are our responsibilities as we colonize other planets? How do we balance technological progress with the protection of extraterrestrial ecosystems? The rapid pace of exploration will require careful thought, collaboration, and the development of legal frameworks to guide space exploration and resource utilization. These challenges will not only require scientific and technological solutions, but will also demand that humanity approach space exploration with a sense of responsibility toward both Earth and the cosmos. The journey into space is a collective endeavour. As 3I/ATLAS continues to expand, it provides not just a scientific exploration of the cosmos, but a broader vision of humanity's place in the universe. Space exploration will depend on our ability to collaborate, innovate, and remain grounded in our shared values. The path forward will shape not only the future of space exploration, but the way we choose to live and evolve as a species. The future is uncertain, but with 3I/ATLAS as a guide, humanity is prepared to embark on the most transformative journey in history. The road ahead is filled with challenges, but also boundless opportunities. The legacy of 3I/ATLAS will not just be defined by the data it collects or the technologies it develops, but by the spirit of exploration and collaboration it inspires. As humanity moves forward into this new era, we are reminded that the stars are waiting for us, and the adventure has only just begun. As 3I/ATLAS continues to transform our understanding of the cosmos, it underscores a significant truth. The future of space exploration is not just about technological advancements, but about shaping the trajectory of humanity itself. Every discovery made by 3I/ATLAS, whether concerning the deepest reaches of space or the next technological breakthrough, adds a new layer to our collective knowledge and highlights the enduring connection between space and human progress. One of the most profound impacts of space exploration is its ability to drive innovation across various fields. The challenges posed by space's harsh environments have led to the development of cutting-edge technologies that have far-reaching applications on Earth. For instance, medical advancements such as improved diagnostic tools and telemedicine have benefited directly from space-related technology. Similarly, breakthroughs in materials science, initially designed for space missions, are now being applied to construction, manufacturing, and other industries. The technologies pioneered for space exploration often find critical applications that improve life on Earth. For example, life support systems developed for space habitats, including air and water recycling systems, are now being applied to sustainable living on Earth. Additionally, AI systems designed to analyze vast amounts of space data have been instrumental in machine learning, data analytics, and even healthcare, finance, and logistics. Space exploration serves as a testing ground for technological solutions that ultimately benefit all of humanity, pushing us toward a future where technology and sustainability go hand in hand. Moreover, the potential for space exploration to unite humanity is one of its most powerful aspects. 3I/ATLAS brings together nations, institutions, and private enterprises in the shared pursuit of knowledge, emphasizing the idea that the cosmos belongs to all of us. The collaboration needed to make 3I/ATLAS successful highlights how, despite our differences, humanity can come together to solve complex global challenges. Space exploration is no longer a national endeavour, it is a human endeavour. As we develop the technologies necessary to explore, understand, and colonize other planets, international cooperation will be essential. We must work collectively to manage space resources, establish ethical guidelines, and ensure that space exploration remains a domain for cooperation rather than competition. The future of space exploration will be shaped not only by technological breakthroughs and international partnerships, but also by humanity's approach to sustainable living in space. As permanent colonies on the Moon, Mars, and beyond become increasingly feasible, our way of life will need to evolve. Space will force us to rethink how we use resources, recycle waste, and adapt to extreme environments. One of the greatest challenges will be developing closed-loop ecosystems for long-term space habitation. The ability to recycle air, water, and food, as well as grow crops in space, will be crucial for the survival of astronauts and the long-term success of space colonies. This shift in how we think about sustainability will also impact life on Earth. The technologies developed for sustainable space living may eventually be adopted here to address issues such as resource scarcity, overpopulation, and climate change. By finding ways to live self-sufficiently off Earth, humanity will discover innovative solutions to many of the problems that challenge our planet today. As space exploration advances, ethical considerations will become more pressing. The potential discovery of extraterrestrial life, whether microbial or intelligent, poses profound questions about humanity's place in the universe and our responsibility toward other forms of life. When we explore other planets and moons, we must consider the potential ecosystems that may exist and take steps to ensure that our actions do not harm or contaminate these environments. Furthermore, the commercialization of space and the extraction of resources from celestial bodies will raise ethical dilemmas. How do we ensure that space resources are used for the benefit of all humanity rather than a select few? The answers to these questions will shape the policies that govern our actions in space and determine whether we approach space as a new frontier for cooperation or exploitation. As 3I/ATLAS continues to uncover the mysteries of the universe, it is important to remember that this is just the beginning of humanity's journey into space. The discoveries and innovations sparked by 3I/ATLAS will lay the foundation for a new space age, where exploration, sustainability, and global cooperation are at the forefront. With each discovery, we move closer to the possibility of interplanetary living, interstellar exploration, and an expanded role in the cosmos. The future of 3I/ATLAS, space exploration, and humanity itself is wide open. The questions we ask today, the choices we make now, and the technologies we develop will shape the path ahead. One thing is certain: the journey will continue, and humanity's unrelenting spirit of curiosity, innovation, and exploration will drive us into the stars. With 3I/ATLAS laying the groundwork, humanity stands ready to embrace the endless possibilities that lie ahead. The cosmos is vast and our potential is limitless. The road to the stars has just begun. As 3I/ATLAS unfolds its journey, pushing the boundaries of space exploration, its impact extends far beyond scientific discovery. The project is not just a technological marvel, but a transformative force for humanity, guiding us into new frontiers of knowledge, sustainability, and global unity. As 3I/ATLAS continues to expand our understanding of the cosmos, it sets the stage for a future that redefines not only how we explore space, but also how we can create a better world here on Earth. Historically, space exploration was dominated by national competition, with the US and the Soviet Union leading the charge during the Cold War. This rivalry highlighted the tension between competition and collaboration. However, 3I/ATLAS marks a significant shift in this paradigm, focusing on cooperation rather than competition. With contributions from scientists, engineers, and researchers across the globe, 3I/ATLAS embodies the power of international collaboration. The success of this model demonstrates that space exploration is not a zero-sum game, but a shared human endeavour that transcends national boundaries. This shift is not only transforming the way we approach space, but also offering a model for addressing complex challenges on Earth. The lessons learned from 3I/ATLAS's cooperative approach will be essential as humanity looks to the future of interplanetary colonization. The Moon, Mars, and other celestial bodies hold promise for long-term human habitation. However, such endeavours will require global collaboration through treaties and agreements that ensure fair resource sharing, planetary protection, and peaceful exploration. The framework of cooperation established by 3I/ATLAS will become a cornerstone for how we manage space resources and navigate interplanetary governance, helping us avoid conflicts and create a unified vision for space exploration. In parallel with these diplomatic shifts, space exploration through 3I/ATLAS is driving innovation that directly benefits life on Earth. Technologies designed for sustainable living in space, such as closed-loop life support systems, space-based solar power, and advanced recycling methods, offer groundbreaking solutions to Earth's environmental challenges. For instance, 3I/ATLAS's research into resource management on the Moon and Mars, such as extracting water and minerals, holds promise for solving issues related to water conservation and sustainable mining practices here on Earth. Additionally, space-based solar power could provide an almost limitless supply of clean energy, helping to reduce our reliance on fossil fuels and mitigate the effects of climate change. The need for self-sustaining habitats in space is also pushing the limits of environmental engineering. Technologies developed for closed, regenerative ecosystems in space could revolutionize how we approach urban sustainability on Earth. By integrating space-derived solutions into urban planning and resource management, we can create more resilient cities, reduce waste, and promote a circular economy. The innovations driven by space exploration are helping us think differently about sustainability, providing tangible solutions to some of the most pressing issues facing our planet. However, beyond the technological and environmental impacts, 3I/ATLAS has the power to inspire future generations of scientists, engineers, and explorers. The dream of space has always been a source of wonder and inspiration, motivating countless individuals to pursue careers in science and technology. 3I/ATLAS serves as a beacon of possibility, reminding humanity that the unknown is not something to fear, but something to embrace. The technologies and discoveries emerging from space exploration will not only deepen our understanding of the universe, but also help us solve the problems we face on Earth. The exploration of space is a critical step in humanity's ongoing evolution, and it serves as a testament to what we can achieve when we unite under a common goal. Looking forward, the future of space exploration is filled with both opportunity and responsibility. The lessons learned from projects like 3I/ATLAS will shape a future where humanity is not only united in its quest for knowledge, but also equipped to tackle the challenges of both space and Earth. The project is a catalyst for innovation, providing solutions to global issues while expanding our reach into the cosmos. As 3I/ATLAS continues to gather data, uncover cosmic mysteries, and push the boundaries of exploration, it will guide humanity toward a future where space exploration is not just about unlocking the universe's secrets, but about creating a more sustainable, equitable, and collaborative world. Ultimately, 3I/ATLAS is not just about the stars, it is about humanity's ability to work together, innovate, and build a future that exceeds our current limitations. As we venture into space, we must remember that the journey is not only about the destinations we reach, but also about how we evolve as a species. The final frontier is not merely a place, it is a path we're already travelling, shaped by our curiosity, drive, and collective vision for the future. The stars await, and with them, the endless possibilities of what humanity can achieve. The adventure has just begun. As 3I/ATLAS unfolds its future, it becomes clear that its impact will stretch far beyond the boundaries of space exploration. This groundbreaking project is not just about technological achievements or scientific discoveries. It is a catalyst for reshaping humanity's place in the universe. The journey of 3I/ATLAS is ultimately about transforming the way we think about our future, not just as individuals, but as societies and as a species. The road ahead is full of both unprecedented challenges and extraordinary opportunities. One of the most profound impacts of 3I/ATLAS is its potential to unite humanity under a shared purpose. Historically, space exploration has been driven by national ambitions, with competition between nations defining the space race. However, 3I/ATLAS is shifting that paradigm, demonstrating that space exploration is better suited as a global endeavour. By fostering collaboration among countries, institutions, and private enterprises, 3I/ATLAS is proving that the quest for knowledge is not limited to one nation, but belongs to all of humanity. The future of space exploration, shaped by these lessons, will move toward a unified approach. This collaboration will not only accelerate our exploration of the cosmos, but also provide the foundation for solving global issues here on Earth, such as climate change, overpopulation, and technological inequality. Through shared space initiatives, the insights we gain will empower us to face humanity's most pressing challenges with innovation and cooperation. As 3I/ATLAS continues to make unprecedented strides in space science, it serves as a stepping stone toward the long-term goal of interplanetary colonization. The Moon and Mars are the next logical targets, and as we push forward, the dream of establishing human colonies on distant celestial bodies, moons of Saturn, or even exoplanets in other star systems, becomes more plausible. The biggest challenge in colonizing other planets will be ensuring that these settlements are self-sustaining. For humanity to thrive on Mars, the Moon, or beyond, we will need to create environments where people can live, grow food, recycle water, and generate energy without relying on Earth. Advances in closed-loop ecosystems, resource extraction, and energy production critical to space missions, are being tested in projects like 3I/AT-LRCS, which will lay the groundwork for long-term space habitation. While today human space exploration is confined to short-term missions, tomorrow's developments could lead to permanent outposts beyond Earth. If the technological progress driven by 3I/AT-LRCS continues, a permanent human presence in space will soon transition from an aspiration to reality. The importance of sustainable autonomous life support systems, energy generation, and resource recycling will be key to creating viable off-world habitats. Mars, with its potential for resource utilization and similarities to Earth's day-night cycle, could be the first destination for such colonies. The data from 3I/AT-LAS will guide the development of infrastructure and the identification of local resources that can be leveraged for survival. These colonies will not only be outposts for scientific research, but also for building humanity's first permanent communities beyond Earth. The ethical implications of space exploration will become more significant as we venture further into the cosmos. As we explore other planets and moons, we must also consider how our actions affect these environments. The discovery of extraterrestrial life, whether microbial or intelligent, will force humanity to confront philosophical and ethical questions about our place in the universe and our responsibility to protect other forms of life. Moreover, as the commercialization of space becomes a reality, through asteroid mining, space tourism, and space-based solar power, we will face critical decisions about how resources are extracted and who benefits from them. The answers to these questions will shape future space policies and governance, ensuring that space remains a domain for cooperative progress rather than exploitation. The journey into space is not just about discovering new worlds, it is about advancing the human spirit. Space exploration reflects humanity's intrinsic drive to seek knowledge, to reach beyond our immediate surroundings, and to understand our place in the universe. This spirit of curiosity, wonder, and adventure has driven explorers throughout history, from crossing oceans to reaching the skies, and now to the stars. As we push toward interplanetary colonization, we must keep in mind that the true purpose of space exploration lies not only in the technologies we develop or the data we collect, but in the personal and collective transformation it inspires. The sense of wonder that accompanies space exploration is part of what makes us human, and it is this very spirit that will ensure that the legacy of 3I/AT-LAS continues to inspire future generations of explorers, thinkers, and innovators. Ultimately, the legacy of 3I/AT-LAS is about more than the milestones of space exploration. It is about a new vision for humanity's future, one that embraces collaboration, sustainability, and the quest for knowledge. As we continue this journey into the stars, we will not only redefine the boundaries of space, but also our understanding of what it means to be human. The future of 3I/AT-LAS and space exploration will be shaped by our ability to adapt, innovate, and work together. With each new discovery, we move closer to a future where humanity takes its place among the stars, forging a new path forward for generations to come. The stars await, and with them, the endless possibilities of what we can achieve together.